participating this workshop with you guys. So if you guys have any questions, feel free to raise your hand. It is a hybrid event, so just be aware of that. And then I'll read the floor.
Hello, as introduced, my name is Wiley Kuhn. I'm the Director of Software Development for KIS. This is our introduction to Python workshop. That was our club president, Carmen. This is our annual introduction to Python workshop. We teach this every semester, how people get like a handle on the programming language. It's a very useful resource if you're doing something like CIS 2300. They use Python in that class, or at least they do in mine. It's very beginner friendly. We're going to start from the assumption that you kind of don't know it today. And then we'll go from there. Feel free to leave questions, comments in the chat. Feel free to yell them out at us. I'll help answer them. They can also help answer them. These are, this is Alicia and Jeremiah. They're associates of software development for the club. I'm going to, right quick, we're going to talk about comments. So first thing you should know, when you're reading Python code, it's probably should be documented. You should probably tell people what you're trying to do. Comments are just that. They're just text of string. They do not get interpreted by like the Python interpreter as APJAX. It's solely there for human eyes to read, to explain things. They can be single lines using the pound sign, or some people call it the hashtag. And then if you can use triple quotes and either single or double quotes and have multiple lines. This is also how you do dot strings within functions. That's a little bit beyond that right now. And so if you want to hit run right quick, this is our print function. This is how you print output to the terminal. Oops. That one all the way down here. Yep. So you print output to the terminal. Anything you put within the print function is syntactically correct. Should print. So now we have our first Python program. This is Hello World, and it is printed Hello World to the terminal. I'm going to turn it over to Alicia. She's going to take the next section of this Python workshop.
So the first thing that I'm going to talk about is the print function, as Wiley was just talking about. It's a built-in function in Python that we can use to print out anything that we want in the console. So the first example here we had print hello world. It's in double quotes. So this is a string that we're printing out, and I'm going to talk later about the types. And then you can also use single quotes for the strings. And then if you print out, I'll just run it and show you guys what it looks like. So if you were to print out like nothing inside of the parentheses, then it'll just print out like a line, blank line of space. If you want to break your line apart, you can do that. And otherwise, everything will just print right after the other. There'll be a line between each print function. So the first type of data type that we have in Python is strings are anything that's encapsulated between quotes. It can be single quotes or double quotes. Either way, it's going to be a string. And if we print out the string, it'll just print out directly as it is. And if we print out the word type right before our print function, that's basically also a built-in function, and it's going to tell you what type of data type that we have here. So in this case, it's a string, so it is going to say class string. That's what we have in here. And then we just have some more print functions here as well. These are all strings, single quotes, double quotes. These all count as strings. Then the next data type we have is integers. So integers, basically, you would put them the same way in the parentheses in front of the print function. However, you don't need to put any quotations. If you put quotations, then it's going to be interpreted as a string. And if you want to use integers, you put no quotations whatsoever, and it'll give us 100 integer for both positive and negative values. But also note that integers have to be whole numbers, no decimals, no fractions, nothing. It's just only counting by once. And that's it, positive and negative values. And we can use integers to do different mathematical operations. So for instance, if we want to do some addition, just put the plus sign between. So 1 plus 1, that'll give us 2. And that's also printing out as an integer, not a string. That's important. And you can do subtraction as well. 2 minus 1 gives us 1. Division, we use the slash in between the two numbers, and that'll give you the division, so 1.5. It does give the decimal when you're dividing in Python. It doesn't do this in all languages, but in Python, it does give us a decimal. Then multiplication, we just use the star in between the two numbers. So 4 and then the little star times the 2 will give us an 8. Then there's something that's kind of interesting. It's called modulus. The modulus function is you might know it as the percentage sign. It basically gives us the remainder when you're dividing two numbers. So if you were to do 10 and 3, right? It's basically how many times does 3 go into 10, which would be 3 times, which gives 9, and the remainder would be 1. So the modulus just prints out the remainder, which is 1. Then to do exponents, we would just do double stars. So 5 and then 2 stars, and the 2 give us 5 to the second power, which gives us 25. Now, the next data type we're going to be talking about is floats. Floats are basically where the decimals come into play. Since we didn't use any decimals or any fractions in integers, floats are where you can do that. So, for example, we have the first one is print 69.9, and you can't really see that down here, but it will just print it out just like that, and it'll give us the class is float. And we can use all of our mathematical operators the same way. So something I do want to note here is you can see we have a string right here, and then we have the integers right here. So this string, this red text, won't actually do the mathematical computation. It's just going to print out 1 plus 1.1 plus 1.1 equals. It's not actually going to do the math. And then if you want to do the math following, we have the actual 1 plus 1 with no quotes around it. 1.1 plus 1.1, that'll actually do the math for you. And that will print out, as you can see, just like this, down here. And the same applies for everything else. Then another thing we have when we're using floats, if you per se don't want to have the super long decimal value, so if we have 24.6 divided by 11.9, that's going to be 2.067222, and etc. Let's say you don't want that whole long decimal value. You can just use basically a double slash, and it's going to divide it and give it a 0.0 at the end. So it's not going to give you that whole long decimal value if you don't want to use that. Yeah. And then the modulus, the exponents, everything else works the same way that it does with integers. And the fourth data type that we have is Boolean. So Booleans are basically just true or false logical operators. And something that's important is they are case sensitive. So it has to be with a capital T, capital F. Same applies for the print function. It has to be a lowercase p every time you try to print, or else you're going to get an error. So for instance, if we just print these ones out, there we go. So if we print true, that's just going to give us true. And the class for that is going to be Boolean, which is the type that's what the little type operator is doing for us. And then false. These are the only two options we have, true or false, for all of our Boolean values. Good. Any questions? All right, Jeremiah, take it away.
All right, so now we're going to learn about some of the comparison operators. And so you'll see the first one here will have the equal operator, and you'll notice that there's 2, and I'll explain why it's 2 afterwards, but it's basically saying that like 1 is equivalent to 1. And then we have the not equal operator, they'll use the exclamation mark and the equal sign. And this means that 1 is not equal to 1. We have 1 is greater than 1, and then 1 is less than 1. And these are terms that you may be familiar with from your math classes. 1 is greater than or equal to 1. 1 is less than or equal to 1. And you'll see here that when I print this out, you'll see that 1 equals 1 is true. 1 does not equal 1 is false, because we know that 1 does equal 1. 1 is greater than 1 is false. 1 is less than 1 is false. And the bottom two, I'm sorry. The less than or equal to is also true, and the last two are true. And the last one is false, because you'll see that Milo is not equal to my 1. And these are 2 things. So now we'll get into some of the if statements. And this is basically just saying, if this is true, the following statement will execute. So, for example, we have here, if 100 is equivalent to 100, it will print this is true. For the next one, we'll see that it says, Oh, yeah. And we'll see that it doesn't print because it's not, 100 is not equal to 100. So it's not going to print, this is true. And for the last one, we'll see that if 100 is equal to 100, print this is true, else print this is false. So this should print this is true as well. And we have it here. Next, we'll get into if else statements. And this is basically just saying if, this is basically just saying if the first statement is not true, then do the second statement. So if 100 is not equal to 100, it's going to print the statement is true. If 100, if this statement is not met, if this condition is not met, it will print out the else. Therefore, we got the statement is false because 100 is equal to 100. Then we'll get into the if else. And this is basically just use elif whenever you want to have multiple else statements. So if Scooby is equivalent to Velma, Scooby will print Scooby equals Velma. If not, if Scooby isn't equal to Velma, we'll print Shaggy is equal to Scooby. And if none of these conditions are met, then we'll just print the last statement. And we'll see that it prints none of them are the same characters because none of these names are the same. None of these strings are the same. And the last section we'll get into is variables. And ultimately, a variable is just like, it's a storage unit. So whenever you want to set something equivalent to something, you would use the assign sign, which is a single equal sign. So you remember that a double equal sign means that you're equivalent, and a single one is to assign a value to a variable. So we'll see here that we're assigning the cat to Milo. So when we print cat, it's going to print out Milo. When we print cat, it'll print out Milo and the class of the cat, which was a string. And we'll see that it's a string because of the quotation marks. Another example would be for assigning the variable color to black and white. We'll see, and the age is equal to 6, we'll print cat, and it should print out black and white. And age with the string weeks old, so it will print 6 weeks old. And you can also redefine variables, meaning that you can change the value that's assigned to it. So if cat is equal to Milo, it will print this one first. And then if you reassign cat to Milo with an I, it will print out the second one. So you'll see here that we printed out the first Milo with the Y and the second Milo after it was reassigned. And even though Python does allow you to do this, we don't recommend it because it can confuse you like later on in your code. So yeah, and we can also reassign variables to other data types. So for example, we'll see that age is set to 6 and there's no quotation, so it's an integer. And we'll print this out. Okay, we'll print this out and we'll see that it's an integer here, class, and we'll print age. Then we printed out the empty space, and now we can change age from a float, from an integer. And that's why it will print 6.0, because it's a float now. It's no longer an integer. All right, and so now we can also use casting, which is a form of changing a data type. And we'll see here that fingers is set to 10. and we'll print out fingers in the type and prints out 10 fingers, and that type is an integer, and now we change fingers to a float, and it prints it out as a decimal. And we change it to a string here, and it changes it into a string. Although it looks like an integer, we know that it's a string because of the class here. And Boolean, which is basically a true or false comparison operator is basically saying is bool equal to 5, and we see here that's 5. So, and we set it here. So that's why it prints out true. We set it here to 5 with the string. So we'll see here that casting doesn't work for all conversions. So for example, if you wanted to convert, we'll try to convert the string hello world into an integer. It can't do that because like hello world they are words, they can't be converted into a number data type. So that's why we get the error here. And it'll say invalid literal for int. And here again, we'll see that we can't convert that. We'll get an error again because we can't convert that into a float because it's a word. And you'll see we'll get an error again, but not convert string to float. Hello world. And lastly, we'll have we can convert strings into number strings into integers because they're numbers. But I guess you can think of it like the absolute value of this 100 string is really 100. So if we converted, if we did a print statement of an integer of a string of 100, we'll actually be able to run the code and it'll execute as 100 and change type to an integer. And lastly here, this is basically, so this is a list. Why we will get into this later, and we'll see that if we assign X to this list, 1, 2, 3, 4, and we print out, and then we assign another variable to the previous variable, it's basically like you're pointing, if you printed out the second variable, you're pointing to the first one. So if you, for example, you'll see here, x.append, it means that we're adding 5 to the list. We'll see that when we change X, we appended 5 to X, but it also appends it to Y because Y is equal to X. And that'll be all for variables. I'll hand it over to Wiley.
Yeah, basically what it is I've seen a bunch of people encounter this, which is why I wanted to put it in here. Is essentially what you're doing is when you say Y is equal to X, you're not actually creating a new list. You're just pointing Y to the exact same storage space of this list. So when you alter this list from X, it actually does alter it to Y, which is a really interesting quirk and has frustrated some people that I've known. Okay, so when we talk about programming languages, we do have to talk about the human element, right? We have to talk about the fact that we need input from human beings in order to get our program to do what we want it to do, right? It could be something as simple as a calculator. It could be something as complicated as like a huge like front end, web app. But we need input from human beings. It's crucial. It's kind of the entire reason that these things exist is to do work for us, right? So in Python, we're going to use a built-in function called input. And essentially what you do is put input, any string of text you put in here is what the prompt will be right before you put your input. So here we're going to put Wiley. And you'll see here that the input was Wiley. And then We're gonna do something a little bit more complicated. We're gonna put my first name and my last name, and it's gonna print them out. And you're gonna see right here, that we did hello, plus my name, right? So basically, it's taken this variable, name, it's assigned the string that I type in, which is my name right here, to it. And then we're simply adding it to this string, and then it's going to print the entire text, which is hello, Wiley Two.
Right quick, I want to say that we do have. All right, it's all Ariana. All right, Ariana. Okay. So do we have any questions so far?
I wonder, when you, let's say when you fill out this form, how much
Yes.
of that data is collected and stored in the program, and then how much of it just kind of like that whole world, just like.
So it's an excellent, yeah, so it's an excellent question. Obviously it does have to like take the data and store it in order to like regurgitate it back up, right? In the back end of Python is written in C. So there's like a lot of manual memory allocation going on, as you can imagine. It's basically referred to as garbage collection. My educated guess would be that it keeps it until the program finishes running, at which point it probably just releases it to be used by a computer for something else.
Okay.
Yep. It's not a huge constraint. It used to be massive when computers were like very small and it cost like $10 million to add on like a megabyte of memory. But now with everybody having like gigs and gigs of memory and storage space, like keeping things like hooked in unless you're using like huge amounts of data is not like a massive problem anymore. Right. Okay. So basically, this uses concatenation to combine like these strings. You can only add a string to another string, right? So for instance, if you tried to type this, if you did this in,
Don't quote me on this, I'm gonna say this fits. If you did this in Java, I believe it would work. I think Java actually does concatenate numbers with strings. And it's something that I wish Python did, I don't know why it doesn't, but this doesn't work. This is gonna toss us an error because 6 is an integer and these 2 are strings. Right? We're gonna get, it's gonna highlight this, it's gonna say, this is not correct, don't do this, I'm not dealing with this.
but there's a couple ways to handle this. The first one we're going to see right here.
This is the string operator. It will take any integers, floats, whatever other data type you're trying to work with. It will convert it into a string. And so then you can add these together.
And you will actually get
The output that you want out of the 6.
it's very useful, like for dealing with things where you're like not trying to do math, but you need to add it together. But they're both numbers. In order to do that, you are going to have to use this string operator. You can combine variables here with a comma.
This is not as common, right? It says I am bored. I don't really see the comma used a whole lot in real life. There's, to me, much better ways of putting things together. But if you do comma, it will work. You can put multiple variables into a line that way.
You can also use this separation parameter within your print statement
In order to put things between the numbers, right? So here it's going to basically stick a comma in between each of these numbers, which it wouldn't do, even though this is written here. It would just put a space in between each of these. So we'll put a comma. This one's going to put an arrow. I like using this separation for arrows when I'm using things, doing things like working with linked lists, where I actually do need to kind of visualize how things are pointing to each other.
And so if we run this,
Right, you're gonna see space, commas, arrows, right? And you can use this to basically break up things any way you need them to be.
and then my personal favorite, help. Right.
So this will print out your help statement. For basically all of the things that you can use like within your print statement here.
It's just very useful. I don't know if any other functions actually have it. It probably does. I haven't tried it. The other thing that I would say is, I forget whether we get to them later, so I'm just going to do it right here. Is that there's a thing called F strings. And this is, in my opinion, the best way of combining things. Which is, if you do your print statement, you put an F before it. And then within your print statement, you can just type name is, and then use curly brackets. And anything you put, any variable you put in there will automatically basically be reduced down to string and outprint in the print statement. So put name. I like this because it's incredibly easy to look at. It's very logical. There's no kind of like auxiliary functions to look at with the string function that we were looking at before. It's very readable. And like, to me, and it's very like, it makes a lot of sense when I'm typing it out. Like, right, like my name is this, I am this years old. And then when you run this, it reduces it all to string and you'll get your desired number, right? My name is Wiley, 33 years old, right? That to me, this is the best way of doing things. That's just a personal opinion, but it's just incredibly logical. All right, so we're here to lists. Lists are basically just an array of data. They can contain as much data as you want. They can contain any type of data you want. They can be strings, they can be integers, floats, classes, bools, whatever you happen to need to stick in the list. Typically, it'll be more organized than that because you'll have like an actual like vision project that you're working on and like a storage space that you need for certain types of data. But if we print this list, it will just print the list, but it'll print class lists, right? Because we've got type characters here. And again, they don't need to contain the same amount of data, the same type of data, right? This is a valid list. It will output, whatever is in here. You won't get any errors out of it. I like this a lot better than a lot of other programming languages that will force you to have the same type of data in different arrays. It's one of the reasons Python is my favorite language is because of the flexibility it gives the user instead of forcing you to like adhere to sets of often arbitrary rules written by nerds 30 years ago and never changed. Right? And so here, since lists are ordered using indices, we can access elements of them. So what are indices? They're basically the way you would access these pieces of data. They're how you refer them. So we have a list. It's called alphabet. We have our square brackets. We know it's a list. So if we print 0 and 4, you're going to see we're going to get A and we're going to get B. Here's a cool little piece of knowledge that I see kind of people not know. Does anyone here know why this starts at 0? Like, why not at 1? This is the first element in this list. Excellent. I'm about to tell you. These are actually memory locations. So physically on the hard drive, what happens is that this variable basically points to this plus n number of memory locations next to it in the storage space. So when you are doing this, when you say, so this is the original piece of data, right? It needs to go 0 n number of memory locations. This is telling you need to go here plus 4 memory locations. That's actually why these indices work the way that they do, right? It's a very cool piece of information. Not a lot of people know it. I had to Google it because it frustrated me, and now that I know it, it makes a whole lot more sense. We could also refer to lists backwards, starting from -1. Right, so if you put in -1, you're going to get E, and if you put in -5, you're going to get the first in the list. Is this the equivalent of using the format function? I assume you're referring to the F strings. I do not know about the format function. If that is from Java, it's not in my realm of expertise. I deal with Java as little as humanly possible. It's a good question though, and I will have to look it up. So again, we have our list of characters here, right? All from Scooby-Doo, plus Milo, which I think is somebody's cat. So if we print this, we're gonna get our full list. And then we're gonna get Scooby, then we're gonna get Daphne and Milo, right? Because we have 0, 4, and 5. Excellent, good. And again, do we have any questions? I know I'm kind of talking everyone's heads off here. All right. So there's another way that we can access elements of a list, and that's through string slicing, which is super crucial. And you basically do this through colons. There's actually, we'll probably get to it. Yeah. So down here, where you have it's broken up by colons, you have basically 3 slots. I'm going to skip a little bit so you can understand this. It's start, step, it's start, stop, step. Right? With stop being exclusive and step being how many things you're moving within the list, right? So if we have characters 1 through 4, and we saw up here that we have our list of characters, right? It's going to take characters 1, 2, 3. We're going to get these 3. 4 is exclusive. It's not going to be included, even though it says 4 right here. Right? Shaggy, Velma, Fred. 1, 2, 3. We exclude Daphne, and it basically gives us this subsection of the list. This is incredibly important because this is possible not just with lists, but also with strings. You can take strings. You could use this, for instance, to slice and take the first like X number of characters from somebody's first and last name. Or if, say, you wanted to print somebody's initials out, you could simply use this to take the first letter of their name, or like the first 2 letters of their name. Like if you see abbreviations a lot, that would be incredibly useful to do with this. It's a really slick way of doing things. We can also do from a certain point to the end, right? So we're going to go from the 3rd index, which is 0, 1, 2, 3, all the way to the end, because there is no stop, right? So you'll see here. Oh, that's going to give us all of them. I accidentally skipped this cell, but because there's nothing here, it's just going to give us all of them. If we then run again, we're going to get from 3 to the end, which is going to be Fred, Daphne, and Milo, right? And Scooby, Shaggy, and Velma, because it's on the other side, it's going to go actually, it's going to go from the beginning to the 3rd index, right? 0, 1, 2. So it's going to exclude this 3rd index. You get Scooby, Shaggy, and Velma right here, all due to the magic of string slicing. It's done with square brackets attached to the end of things. You'll see this a lot in Python as well when you're accessing like keys and dictionaries, which we'll get to a little bit later, but also if you start doing more complicated things like working in JSON, that's where that will go. Things of that nature. They all tend to use square brackets, and it's incredibly useful. So lists are very good. They're mutable. We'll get to a data type called tuples, which are not mutable later on in the presentation. But basically, we can add things to the list. We can change elements of it, right? So we have our list of characters again. We change the 4th character, which is going to be Daphne, to Bogle by accessing the index. And again, we're going to use this assignment operator. Characters 4 is going to equal Bogle. we're gonna see it actually changes the output, right? Daphne gets replaced by Bogle. The list is the same length. Our fourth element is different. So lists have a bunch of great built-in methods for helping us alter them. So this is the append method. Append just means add to the list, right? So if we see here, we have our video game characters from Mario, Luigi, Peach, Daisy, Toad, Yoshi. If we want to add Donkey Kong to this, we're going to use the append function on the characters list. It's going to add Donkey Kong to the end of our list. Perfect, right? And then we can see the list is actually longer. I've done this, for instance, to like randomly generate a shuffle of a deck of cards using a little bit more than this, but basically just the pop and append functions and the random dot choice. And you can generate an entire deck of cards this way in order that the append function just adds things to our list, right? We can also pop things from our list, which basically removes them and it assigns them to a variable. This is very good if you want to use a list to process a bunch of data. You don't want to do each element twice, right? You don't want to go through, say, each name or each piece of data on here twice. If you want the string, like the list to be empty after you're done with it, you would just use this. So we're going to have this. We're going to pop the fourth element of the list, which is going to be Toad. And then we're going to print it, right? Because we've got it assigned to this pop variable. So basically what it does is it deletes Toad from this list, assigns it to this variable, and then we can print that out or do whatever we want with it. So this is the index method. The index method is basically for searching, right? So we need to be able to find data in order to use data. So what this does is it's going to return the first index of the specified element to this. So we have Peach, it's going to return 2. If we had Peach also at the end here, it would also return 2. It's going to return the first found index of whatever it is that you're searching for within the list. Right, so you're going to see it returns 2. I'll show you that if I go in here and I did this, you would still also get 2. Right, it's just going to hit this one. It's going to find the match. It's going to tell you the location where that match is. It stops right there. It does not continue going down through the entire list to find the second one. The sort method rearranges these elements of the list so they appear in ascending order. Basically, what this is going to do is it's going to take this, it's going to start at 0, it's going to sort these from smallest to largest, from left to right, and it's going to allow us to print them all out. And then, does anyone know exactly what's going to happen if we use sort on string data types in this example? Does anyone want to take a guess? Your first guess is probably good. Alphabetical, absolutely. 100% if it's in alphabetical order. So if we run this, yep, you'll see we get this list sorted, and we get this list sorted by alphabetical order, right? And this is the reverse method. It's incredibly simple, just reverses the whole thing, right? So for instance, if you were doing, if you were having to work with data and you sorted it, and then you needed to go from ascending to descending, in which you need the largest numbers first, going all the way to the smallest numbers, this would also work for you. You'll see. Now we're reversed, right? We have it in reverse order. These are the most popular ones. Now we're gonna get to tuples. I have a little fun thing in here for tuples for us, but tuples are basically immutable. You can't change tuples. I sort of just lied to you. We're gonna get to that in a second. But fundamentally, you can't change tuples. They are created using just the curved brackets. Once they're created, you're done. You can't like add data, like you can't change data within a tuple. We can extract data from a tuple, kind of like we did with the string slicing. Right? So if we see here, you'll see we have basically our same array, except we're using curly brackets, which is how you know it's in a tuple. And you'll see here that we can use string slicing to get things out of it. Now, if we try and reassign this, we're going to say that this character, P, is actually equal to 1000. Because this is an immutable data type, it's going to throw it there. Right? Tuple object does not support item assignment. You can't change it. Now, once it's created, fundamentally, completely inalterable. If you need to have data that you don't want a program to change at all, this is how I would do it. And since they're immutable, they kind of have like limited methods, right? We can't really do a huge amount to like the stuff inside of it. We can't really like sort it or anything like that. It's just there. But there are some things we can do. For instance, we can count the number of times something appears in an array, right? So if we do count 1, it'll tell us that this appears 3 times. Right? If we were to do 2, it would do 2 times, 3, 4, and 5 would each be 1. The index method allows you to find, again, the first index of an element within a tuple. Although I don't know why whoever made this did not make this an actual tuple. Right? But it'll tell us index 3 again, right? It works the exact same way as it does in a list. Now, here's the question. I said earlier that I kind of lied to you when I said that you can't change the contents of a tuple. The answer is you can sort of change the contents of a tuple in very weird specific ways. But we can change the contents of the element within a tuple if the contents of that element are mutable, if that makes sense. So if we create a list, it says Wiley, my favorite animal, it's the raccoon, and the tuple is that list, right? And we append Python to this. You will see, right? Wiley, raccoon, person 33, right? So you're going to get this list of Wiley, the raccoon, page 33. I then append Python, that's my favorite programming language, to this list. And it actually does change the contents of the tuple because this sub element of the tuple called tuple is actually just a pointer to this list. So I can alter that list, and then when this runs and it prints I can change the subsection of this, it changes this list. When this then runs, the tuple gets interpreted, it pulls the piece of information that is mutable, and it has changed. So you can do weird little things to it. We can also use the plus equal operator on a tuple. Oh, no, we can't. I could have sworn we could have done this. I tested this. Blah, 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 blah. All right, ignore me on that one. That worked earlier and I don't know why. So we're gonna move on to dictionaries. A dictionary is a different type of content of an array. So with our list, we had an array of data, and within that array of data, we could access it using indexes. There's a much better way of doing this. They're called dictionaries. Dictionaries store their data in key value pairs, right? So Mario has a value of 10. We can then access each of these pieces of data using its corresponding key, right? So if we print this out, you'll see that we have, it'll print our dictionary. We're using curly brackets. That's how you know we're printing the dictionary and not some other type of data. You can also arrange it like this. I've seen them arranged like this. It's a very good visual way to do it. It doesn't actually change anything about it, right? As long as you've got your comma in between your numbers, except for your last one, slap them between the two curly brackets, you're good to go. And so now, when I told you that we access a lot of stuff with these square brackets, right? So right here, we're accessing Toad. What we're doing is we're saying, get me the value that's stored in under Toad, under the corresponding key, right? Which is 5. And so we'll do that and it will print out 5. Again, if we do this for a key that is not within our dictionary, so we don't have Bowser in here, right? If we try and access the Bowser key, we're going to get an error, right? It's going to give us a key error. It's going to tell us that Bowser is not in the dictionary, and it's going to just immediately stop our whole program until we fix it. So since Bowser's not part of the dictionary, we're going to get an error. To avoid getting these, you can use this get function. And what will happen is that if it's not in there, it just returns a none. It won't stop your program. You'll just get a return data type of none. This get is very useful, especially in debugging. I've changed a bunch of stuff to get, and then you find the one that's causing the key error, and then it helps you narrow things down. And so to add something into the dictionary, we can do this essentially the same thing that we did, the way we did with lists, right? Where we had the list name, and then we had the square brackets, and we put the integer of the data that we wanted to add, or we could just add a plus to add it on to the end. You do the same thing, you just do it with the key value, right? So dictionary Bowser is equal to 10. So when we run this, we will get our previous list. And then you will see here that afterwards we have our previous list, but now we do have Bowser as a key, and it will be equal to 10, right? Because we've said in this dictionary, create a key with the Bowser with a corresponding data value of an integer of 10. Let's see here. If we want to delete something from a dictionary, we have to use this del key, stands for shorthand for delete. It'll be delete dictionary, because that's our dictionary name, Bowser. And again, you'll see what is it doing? There we go. I didn't run this on before. So you'll see before we added Bowser, right? We do this. We delete Bowser. Nope. It went down too far. Come on. There we go. We added Bowser. We can see that Bowser is here, right? We print the dictionary. We delete the key. We delete the data in the key of Bowser. And you'll see we had Bowser on here before. Now we don't, right? So you basically delete something from a dictionary. All right. In order to change a record from our dictionary, we could reassign the value using the key, right? So right now, we have Mario stored in here. It has a value of an integer of 10. Let's say this is the amount of life that Mario has. Mario eats a super mushroom, a change needs to take place, right? Mario gets tougher. So what we're gonna do is we're gonna go in, we're gonna go into the dictionary, we're gonna go to Mario, and we're gonna set it equal to 20. And so you can see here, nothing has changed except Mario, the value has been reassigned to 20, because that's what we've done up here. Taken this key, we said change the data that key represents to a 20, and it's done that. We've doubled Mario's health. Now we have this dot keys function. This will return a list of just the keys in the dictionary. This is very good if you need to, for instance, write a section of code in which you don't know what the keys are going to be. You can then grab these keys, you can then iterate over these keys and print out all of the values of all of the things represented by these keys within the dictionary. And this will allow you to very quickly access like everything within the dictionary in just a couple lines of code. It's incredibly useful. Correspondingly, if we run values, this will give you their corresponding values, right? Mario is 20, Luigi is 9, Peach is 11, right? This will give you the corresponding values to said keys. So it allows you to kind of break these things apart. There is, I'm trying to remember what the keyword is. There is a way under here to do like, nope. Go away. For key value in dot, I think it's this. Yes. So there's one more called items. And what this does is it actually returns two values that you will need to assign using this syntax here, key comma value, which is the syntax I can talk about if anyone has any questions. It's pretty simple. But it will assign the first one that comes back is going to be the key. Second one that comes back is going to be the value. It's very, very, very useful for breaking these things apart in a loop. In very few lines of code, if you need to like get both the key and the value in order to like, say it's somebody's name and their age and you need both of those, like how do you grab the value of that key? You can do something like this, right? There's a lot more. Obviously, we link to the documentation here. We'll be putting this up. And then one of the last things we're going to talk about, last two things we're going to talk about. One is called sets. So Python is primarily a scientific computing language, although it's become far more general purpose, and there are libraries for it that will allow you to do pretty much anything. But sets are very useful. So sets are exactly what they sound like. They're lists of elements, they're lists of data, and sets allow you to very easily compare these. Right? You could manually kind of write this code. My advice is that the function exists within Python. Use that. I can give you some examples of how insanely faster it is because they're all writing it in low-level C language. They have the advantage of low-level programming and memory allocation that we kind of don't when we're using Python as a high-level language. And it could be thousands of times faster to do it with the built-in functions. So if we create a set of cards, right? We can create this set here. Right? It's going to create our set. And then we'll print our set. They look kind of like dictionaries, except they don't have it. Right? They're just curly brackets. And so we can see these sets. This is the exact same set. They've been created two different ways. Python will interpret this as a set. It will also interpret this as a set.
this kind of manually forces it to be a set. I don't have a huge amount of problems with Python not setting things correctly. I would use this syntax, but they both basically create the same thing. And as you can see, our output here is different from our output here. Because we have repeating elements. So this is simply going to print out all the unique elements within a set, right? They're incredibly useful data structures within Python. They also come with built-in functions, right? So we can do the exact same things to them as we can do to like most other data structures like lists and dictionaries within Python. We can add 6 to this list simply by using this add function or add method, right? So we get our list of unique elements and we now have 6 on it. We can also do the same thing wherein we remove an element. So if we do this, you'll notice that now we don't have 5. We have removed 5 using the remove method, right? They're also important because they apply to set theory, which is more mathematical. But essentially, the way I would describe it is allows us to compare what sets have in common and what sets don't have in common and what combined sets look like. So we have here 1, 2, 3, 4 and 3, 4, 5, 6. So we know immediately just kind of visually that the things in set 1 that are different from the things in set 2 are 1 and 2 and 5 and 6. Sorry. Yes. So if we run this, it's going to tell us 1 and 2 are the things that are in set 1 that are different from set B. And it's going to tell us that 5 and 6 are the things in set B that are different from set A, right? Because 3 and 4 are labels. So that intersection, this is going to show us what numbers are being excluded, what pieces of data. The intersection method basically allows us to do the opposite, right? We're going to see what do these 2 sets have in common. And we're going to get 3 and 4 because 3 and 4 are here and here they are in both sets, right? And we're going to use the intersection method for this. This is incredibly useful, especially like down into like more nitty-gritty programming. I imagine it'd be incredibly useful for things like machine learning or artificial intelligence. And the union method basically just returns both sets combined. 1, 2, 3, 4, 5, 6, right? It returns all of these unique elements of these put together. So now we're going to get into our last module section here. So in programming, one of the most egregious things you could do is write the same code a bunch of times in different places, right? The idea is you want to use one section. If you have a piece of code that needs to be in a bunch of places and it's exactly the same, you can simply define it as its own section and then call it when you need that code to run instead of writing like a bunch of different lines of code every single time, especially if it's like a long section of code, right? Like if you've got like hundreds of lines. So what these are called, they are called functions. They're groups of code. Indentation is incredibly important. Here's a basic example. We're going to define a function called greeting. It takes no arguments and it just prints hello world underneath it, right? And so you can see here, when we invoke greeting, we need to use for our functions, even if there's no arguments, we need to use these curly or the round brackets at the end. This is a very common syntax. You'll see this a lot. And it will print hello world, right? Because what it is actually is it is this whole thing here, including this print statement underneath. It's just represented and stored within this function. We can also put parameters within functions called arguments, and then basically use those in order to affect the output of said function. So here we have define greeting,
print hello, my name is. If we run this, we're going to get an error. Because, oh, no, we're not. I hadn't scrolled down all the way. Okay, I didn't see that. Right. So here's what's going to happen. We have different greetings. We have strings in here. What happens is this string is represented by this variable name. So when you're writing it, you're telling it to take this string, and then you're telling it to put the piece of text it represents here. So it's going to say, hello, my name is, and then the piece of text that's written there, written up here. So they should say, hello, my name is Christina. Hello, my name is Wiley. Hello, my name is Jenny. Hello, my name is Milo, of course. And that's what we get, right? And so that's a way that you can affect your output of your functions simply and easily. There's a whole bunch of other stuff you can do, like give them default values if no value is specified, right? Which is what happens here. But my name is name. So if we don't specify the correct parameters, this is what I was going for, we get an error, right? It yells at us because it's missing a required propositional argument of name, right? We haven't put anything in here. Name has no value and it requires a value in order to fully execute the statement. What we can do is say, if nothing is specified, then this will have a value of Milo, right? Name equals Milo. If you put something in there, it will override this statement. You will just have name is equal to whatever you put in there. But if you don't, the default value is now Milo. And if we run this, we get hello, my name is Milo. I have a question in the chat. Why does print turn red when it's inside a function? Oh, this is just syntax. This is just syntax. This is simply because it's indented underneath this. It would be a different color if I was like in VS Code, using the VS Code theme that I have under there. This is just the syntax that Jupyter Notebook uses. Right? So we can move into more advanced ones. And now we'll see that the parameters, the arguments, you can have basically as many as you want, and as long as you separate them with commas, right? So we can see, hello, everyone, my name is name, and I love my toy plus exclamation mark, Milo, cat tree tower. And since we specified these, it will in fact print out, hello, everyone, my name is Milo, and I love my cat tree tower. Because again, Milo has been assigned to name, cat tree tower has been assigned to toy. We can do this with mathematical operations, right? Which we're going to see down here. So right here, we're going to define area. It's going to be, we'll take the length, and it's going to take a width, and it's going to return the length times the width, right? We're all kind of familiar with this basic math of how you get the area of like a square or a rectangle, right? So if you were building like something mathematical, like you were constructing a program that would allow people to figure out the square footage of a house, this would be something you would probably build, like this exact function, right? And so then instead of writing this everywhere, whenever they needed this, you would just take their input, slap it into the area function or your area, your area function. And what it will print out is that we have a square footage area of 40, right? So again, we can use this. We can do all of our same Python stuff, all of our math, string slicing, everything, anything you can do in Python, you can do underneath a function. And now we're going to do the exact same thing, but for volume, right? So we've got a cube, we've got our length, we've got our width, we've got our height. We have a three-dimensional area. And the area of it is 360 square, whatever measurement they wanted to use here. Inches, feet, meters, that's the area. Excellent. That's been our Intro to Python workshop. It's kind of our crash course. It's a lot to digest in one day, but if you take this, we'll probably put this up in files somewhere for you guys to access. And then, if you have any questions, please ask. I'm more than happy to answer about anything that we just went through. You,
You'll go with the one with the steps.
the one with the steps?
I mean, the steps.
Yeah, absolutely. Yeah, so again, sets are just groupings of data, right? Like any other grouping of data. They are very useful for like comparing one set of like things to another. So you'll notice here we have 3 1s, 2 2s, and then 1 of each of these, but we only have a printout of each of these numbers, right? That's because what it's doing is basically telling us only the unique values within the set, right? So these 3 are the same, it's gonna ignore these 2, it's just gonna give us this one. Again, it's gonna ignore 2, it's gonna give us our 2. So anything there's 1 or more of, because you can't have 0 things in the set, I would assume. It tells us, but it just tells us that that's in there. It doesn't necessarily tell us how many of that type are in there, unless we go down here. I thought there was a count function. That might have been tuples. Yeah, but then basically what happens is the 3 main things you could do with a set is compare them to other sets, right? So if we have 1 and 2 in here, but not in here, right? But 3 and 4 are in both sets. When we print out, we're saying like, tell me what what's in A that is not in set B, right? 1 and 2 are not in set B, right? But they are in set A. So it's going to tell us that. And then we can do the exact same thing, right? What is in set B that is not in set A? 3 and 4 are in set A. But 5 and 6 are not in set A. So it's going to tell us that as well. The intersection is going to do the opposite. It's going to tell us, you know, tell me all of the elements that are in both in set A and also in set B, right? 3 and 4 are in set A, and 3 and 4 are also in set B. So it's going to tell us that those are our common elements. Yep. And then down here, all this does is it combines the 2 sets together, and it tells us all of the elements in that combined set.
So is there a way to find out how many times it's has been?
That's a good question. Nope, that's in a tuple. Go to all reliable. Here we go. Yeah. So if we go back here, we're going to use, I don't know if I have to input count or import this. So I have to input, yeah, from collections import counter. So you do have to use a different collection. One that we didn't talk about, it's a little bit esoteric, deeper into the Python world here. But you have to use what's called a counter. And then do, I think that syntax is correct. Because I didn't do that. Yeah. No, it's still not working. The answer is, I don't know. I've never actually tried to do that. I've never,
But it's possible.
it probably is. I would assume so. It's an excellent question. Are you in our Discord?
I just joined today.
Excellent. Get with me after this presentation. I'll get your username. I will find that answer for you.
Okay, yeah,
And I will get it back to you.
awesome. I have a different question. I want to know, I guess, how much of coding now is being done by artificial, whatever, like, I have a test. And then how much is just big, like, you, like, as long as you know the language, it's like, you know, like, that's how it's.
Yeah, it's,
How much of like sit there and like learn how to actually do the work as opposed to like rely on other tools that are doing it for and just review them, I guess.
so the answer is both. So I have used ChatGPT and things like Google Gemini.
Yeah, they don't work 100%.
They don't work 100% of the time. What I have found them to be incredibly useful for is less kind of like writing code, which it will write basic code very well.
Okay. We won't do complicated.
Complicated, the more complicated it gets, the more kind of it tends to fall apart.
Yeah.
But if you like needed to do a thing for a class where you're like, I have a Excel file and it's got these headings and I need to like merge it with another Excel file using Python and then add up everything, you know, every occurrence of like the first name of Josh.
Yeah.
Like it could probably do that for you pretty quick.
Okay.
What I have found it to be insanely useful for is the thing that I hate the most about programming, which is terribly written documentation. Because it has all of that stuff already like sucked into its metaphorical brain, right? So for instance, I was attempting to build a backend API in Fast API, and I could not figure out why when I sent the JSON data load to the API endpoint wasn't accepting. And I tried for like 2 hours to figure this out. I finally asked ChatGPT and I said, why is this not working? And it immediately spit out.
Like a whole like full documentation like how to do it.
But what it was is it spit out all of the code, which was like exactly the same as mine, like different names, you know, because it uses placeholders or whatever. Except it defined a model for the incoming JSON. It said base model. It said whatever my model may need to be, parentheses base model, because it was extending the base model, followed by the data, each of like the data fields I was trying to have, followed by their data type. And I didn't know you needed to do that. And I went looking for it after that. It worked. Like I built it all in, it worked fine. I went digging, it was like 8 layers deep in the Fast API documentation, buried in like some subclass of a subclass of a subclass. And you needed to know that, but unless you knew where to look, you never would have found it. Yeah, parsing technical documentation, especially if it's badly written, and finding stuff that like you just don't know because people have not put it where it needs to be, is absolutely something I would use ChatGPT or Gemini for on a daily basis. 100%.
But not for the actual writing of complex code, I guess.
If I needed to generate like simple stuff, yeah, like absolutely. Some of this stuff, it will do things like that work, but there's kind of like a simplified, more syntactically correct way to write it. So like if you were to like do it, you get the output like that you wanted, but maybe like the code could be like shorter, more readable, or like use like faster methods, like in some cases, just because it's based on what human beings are, right? We're not like 100% efficient and perfect. So stuff like that, they'll mess up. Absolutely. Any more questions?
You didn't go over grace.
Go over what?
Grace and
No, I didn't go over, we did lifts, like just your standard like square brackets with stuff separated by commas. Nothing connected. Linked lists, we're looking at this semester or early next semester doing a data structures and algorithms workshop. We're still getting like details mashed out and everything. That would definitely be in there. Linked lists are huge. And I would love to do like linked lists and like how to implement like your stacks and queues and stuff like that using a linked list.
okay, that's what I'm learning right now in class.
Yeah, 100%. I would love to discuss them with you. I love linked lists and stuff like that, like doing all your binary searches and
Yeah.
it's phenomenal. It's great fun.
Another question is that I use LeetCode about this.
Great resource, 100%.
Is there any other resources?
My sheer recommendation would be if you want to pass programming interviews, grind LeetCode. LeetCode, 100%. It's just like the biggest, best repository of like programming puzzles in the world.
Okay.
Everybody knows it. They've got, if you're actually like on the job hunt, me personally, I would pay the subscription So I could have access to like, they build lists of like, here are the questions that we know these companies have asked during like programming interviews.
Yeah.
So like if you're applying to like Uber or Google or like some other company, you could find their list that people have compiled and do those over and over again. So that like when you get there, there's like a solid, not totally, there's a solid chance they're going to ask you a bunch of the same questions, right? And that's on there as well.
Yeah.
Yep. Anything else? All right. So we now have my favorite part. We're going to do prizes. So I have, thank you, 2 copies of one of my favorite books, Python Crash Course. It's got a ton of stuff in here. It will teach you Python front to back and more advanced stuff even than we went through in here. And the way you win one. Hold on, I have a chat here. Let's make sure it's not a question first. Yes, if you need to contact me outside meetings, or you can go on our Discord, and in our Discord, you can find me. It's just my name. I have the raccoon profile pic. I was not joking earlier. That is my favorite animal. And you can just send me a DM. Like I'm finding people sending me DMs and being like, hey, what do you know about like X programming thing or X tech thing? I'm more than happy to answer you. So basically, yeah. Yes. So basically what I have is I have 2 code snippets, and the first person either in the chat or in the room to correctly answer what they do gets a copy of the book. So here's our first code snippet. It's kind of blocked by this, isn't it? Let me move it. All right. So the first person who can tell me what this code snippet does, what's it gonna output? Let's find out. You are correct. Can you tell me why?
You do 2 to the 4th power, which is 16, and then the remainder of that one.
Correct. But why would you not hit this?
Because it resulted in 1.
Yes, because this has resulted in a remainder, which then evaluates to like true. Or means it's not going to go in the front. Right. So you're correct. Get with me after this, and we'll have to get like your Empl ID number just for like the club tracking for prizes that we give out. And then a little bit more complicated. Not the same person. Can anyone tell me what the purpose of this code is and what it's going to print out? Yes, if it'll give it away, I won't answer.
No, that's just a set, right? Regular set.
This? No, this is just a regular list.
Oh, regular set.
Yeah, that's just a list.
Is that like an error or 0 or not?
No.
All false.
No. So what this is going to do, I'll give you guys a little bit of a hint. Oh, there was somebody waiting to come in.
Okay. Go ahead.
Hold on. You already answered. Yeah. We're starting here, right, for both of them?
Yeah.
This is a loop that's just going to go over all of these numbers.
Oh,
So just concentrate on this. What is this going to do? No, Yash, it's not 9. Yes. Can you tell me why?
Because it takes the first number, which is 12.
Yep.
And finds the base, 27,
Essentially, correct.
and then finds the lowest.
Yes. So what this does is this starts here. It iterates through this list. And then if none,
Oh.
if it's right, we've set this. Couple of things, right?
But this is greater than.
If it's greater than whatever the set, then whatever the number is,
So
then
they'll stop by 7. Oh.
it won't stop.
It'll run the whole thing, but.
It'll run the whole thing, but it'll set it to the highest value, which is here. And then this does the opposite. Right? So it assigns the minimum value to 3, right? It's gonna go, here's gonna be, yes, that's less than, we're gonna assign 4, that's not. Nothing. 3 is less than 4, we're gonna assign it to 3, nothing, and then it's gonna spit out. It's gonna spit out. Yep. Excellent. So you guys get with me afterwards. Does anyone have any more questions?
We took over the first lift.
Yeah,
That's the greatest one. This finds the beast.
yes, because what's gonna happen, right, is
It goes through everything, right? Because the point is it stops at 47.
it doesn't necessarily stop. What it does is it searches through and it goes, you know, it assigns the initial value to both of them to 12, right? Because that's the
Yeah.
start of this list. And then for X, it goes, it gets to 4 and it says, is this number, is num 4, is it greater than 12? No. So it just doesn't do anything. Is 9 greater than 12? No. Is 27? Yes. Since it's greater than 12, then it's going to reassign the value next to be whatever that number is, which is 27. And then since none of these numbers are greater than, when it hits them, it won't do any reassignment, right? The same thing down here, except kind of the opposite, right? It's gonna start at 12. Is 4 less than 12? Yes. So it's gonna assign 4 to 1. Is 9 less than 4? No. 27 less than 4? No. 3 less than 4? Yes. You're gonna assign 3 to 9? No. 5? No. And you end up with 27. Your minimum and maximum values. Okay, of what's in this list.
Yes.
Excellent. Perfect. That concludes our workshop. I thank everybody for coming. Stay tuned. I think we have.
We have a GM number 2
Yes.
this Thursday, and then we're also gonna have another activity, quote unquote, Jeopardy, you know, I'm creating it right now. And we're hopefully all of you guys can come, because also have another round of prizes. And we're gonna meet a lot of other e-board members and other committee members, because most of them have either a quiz or a test today. So please join us at Thursday. We'll also have a little hint for our next event. So yeah. Thank you for everyone coming, and I think that concludes it.
Thank you.
The prize.